For as long as we have pointed our telescopes toward the heavens, Jupiter has been the undisputed king of our planetary neighborhood. It is a majestic, swirling giant, a colossal ball of gas so immense that all the other planets in our solar system could comfortably fit inside it. We have always seen it as a constant, a stable and mighty presence that has anchored our system for billions of years. Its great red spot, a storm larger than Earth, has raged for centuries, a symbol of its enduring power. This was our Jupiter, a massive, unchanging ruler, the grand protector of the inner planets, using its immense gravity to shepherd asteroids and comets away from us. It was a simple, comforting picture of our cosmic big brother. But the universe, as it often does, had a surprise waiting for us. What if the Jupiter we see today is just a shadow of its former self? Recent discoveries, published in the esteemed journal Nature Astronomy in the spring of 2025, have completely upended our understanding of this familiar giant. Scientists now have compelling evidence that in its youth, Jupiter was an even more astonishing behemoth. Imagine a version of Jupiter that was not just bigger, but a staggering 2 times its current diameter. This wasn't just a slightly larger planet. It was a cosmic titan, with a presence that would have dominated the early solar system in ways we never imagined. This discovery forces us to reconsider everything we thought we knew about the king. This early version of Jupiter wasn't just physically larger, its influence was magnified in other ways too. The new research suggests that its magnetic field was an unbelievable 50 times stronger than the already powerful one we measure today. This colossal magnetic bubble would have stretched far out into space, interacting with the solar wind and the surrounding cosmic material in dramatic fashion. Think of it as a supercharged shield and a powerful engine all in one, shaping the magnetic environment of the entire young solar system. The Jupiter of 4.5 billion years ago was a far cry from the relatively calm giant we observe now. It was a dynamic, powerful, and truly formidable force of nature. This revelation changes the narrative from one of stability to one of dramatic evolution. The Jupiter we see today is not the Jupiter that was born. It has cooled, it has shrunk, and it has settled down over eons. This transformation tells us that planets are not static objects, but dynamic worlds with complex life stories. They are born, they grow, they change, and they mature. Understanding Jupiter's fiery and bloated past gives us a new lens through which to view the history of our own cosmic backyard. We are no longer looking at a simple portrait of a king, but at the epic saga of an emperor who has seen his empire change over billions of years. So how did scientists uncover this shocking secret from billions of years ago? They didn't need a time machine. Instead, they became cosmic detectives, looking for clues hidden in plain sight. The key to unlocking Jupiter's past lay with 2 of its smallest, innermost moons, Amalthea and Thebe. These tiny worlds orbit very close to the giant planet, and for years, astronomers were puzzled by their orbits. They are slightly tilted or inclined in a way that just doesn't make sense given Jupiter's current size and gravitational pull. It was a cosmic cold case, a mystery waiting for the right minds to piece together the evidence left behind. Planetary scientists Konstantin Batygin and Fred C. Adams took on the case. They realized that the peculiar tilts of Amalthea and Thebe's orbits were not random. They were a gravitational fossil record. They were like footprints left in ancient mud, perfectly preserved for billions of years. The scientists used powerful computer simulations to rewind the clock, running the orbital mechanics of the Jupiter system backward in time. They tested countless scenarios, and only one could explain how these moons ended up in their strange, tilted paths. The answer was clear. The moons must have settled into their orbits when Jupiter was a much, much larger and more bloated version of itself. To help us picture this early, enormous Jupiter, the scientists offered a simple, brilliant analogy. Think of a marshmallow. A fresh marshmallow is compact and firm. But if you put it in an oven or over a campfire, it puffs up, becoming hot, bloated, and messy. This is exactly what young Jupiter was like. Shortly after its initial formation, as it rapidly pulled in huge amounts of gas and dust from the surrounding nebula, it swelled up to an immense size. It was a hot, glowing, and far less dense version of the planet we know. A giant marshmallow in the cosmic oven of the early solar system. This puffed-up phase didn't last forever, of course. Over millions and billions of years, the planet radiated its immense internal heat out into space. As it cooled, its gravity pulled it inward, causing it to shrink and become the dense, compact giant we see today. The moons, however, were already locked into their orbits, preserving the memory of that ancient, bloated state. Amalthea and Thebe became unwitting witnesses, carrying the evidence of Jupiter's grander past with them on every trip around the planet. They are tiny time capsules that have allowed us to solve a 4.5-billion-year-old mystery. Discovering Jupiter's larger past does more than just update a fact in a textbook. It fundamentally changes how we view the entire formation of our solar system. The history of our cosmic neighborhood is not a gentle, orderly tale, but a chaotic and dynamic epic. And a supersized Jupiter was one of its main characters. With twice the diameter and a much stronger gravitational reach, this young giant would have exerted an incredible influence on everything around it. It would have been the ultimate cosmic sculptor, shaping the orbits of other forming planets and dictating where material like asteroids and comets ended up. Our entire planetary system was built in the shadow of this immense king. This new understanding has profound implications for our own planet, Earth. Jupiter has long been called our protector, a gravitational shield that deflects many space rocks that might otherwise head for us. But a larger, more massive early Jupiter would have played an even more critical role. Its immense gravity could have been the key factor in stabilizing the inner solar system, helping to nudge Earth into the stable, life-friendly orbit we enjoy today. It may have cleared out dangerous debris from our path, making it possible for life to take hold. In a way, we might owe our very existence to this bloated, marshmallow-like phase of Jupiter's youth. Furthermore, this discovery forces us to rethink our models of how giant planets form everywhere, not just in our own system. The hot Jupiter exoplanets we find orbiting other stars, gas giants that are incredibly close to their suns, might have stories similar to our own Jupiters. Perhaps being hot, bloated, and enormous is a standard phase for all gas giants. By studying our own king's youth, we gain invaluable insight into the life cycles of planets across the galaxy. It provides a crucial piece of the puzzle, helping us understand the diversity of planetary systems that telescopes like the James Webb and TESS are revealing to us every day. The story of the solar system is one of constant interaction and evolution. Jupiter's early size wasn't just about Jupiter, it was about the entire cosmic dance. It would have affected the size and composition of Mars, the layout of the asteroid belt, and the delivery of water and other essential materials to the inner planets, including Earth. Every aspect of our system's architecture was touched by Jupiter's massive presence. The history we thought we knew has been revised, and it's a far more dramatic and interconnected story than we ever imagined. The king didn't just rule his court, he built the castle. This revelation about Jupiter is a powerful reminder of one of the most exciting truths in science. We must always be ready to have our minds changed. Jupiter is just the latest in a long line of celestial bodies that have shattered our long-held assumptions. For decades, we thought Mercury was tidally locked, always showing the same face to the Sun. We were wrong. We discovered it has a clever 3-to-2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits it completes. The universe is always more clever and more complex than we first assume, and it is full of these beautiful surprises. Think about Pluto. When the New Horizons spacecraft flew by in 2015, we expected to see a cold, dead, inert ball of ice and rock. Instead, we were greeted by a stunningly active world. We found vast glaciers of nitrogen ice, towering mountains made of water ice, and strong hints of a liquid water ocean hiding beneath its frozen shell. Pluto taught us that even at the farthest, coldest edges of our solar system, worlds can be dynamic and complex. The universe doesn't follow our simple scripts. It writes its own, far more interesting stories for us to discover. And what about the other gas giants, Uranus and Neptune? For a long time, we dismissed them as bland, featureless blue balls. Voyager 2's flyby, and later observations by Hubble, revealed them to be anything but. These are dynamic worlds with some of the most violent storms and fastest winds in the solar system. They have bizarre, lopsided magnetic fields that are completely different from any other planet. Scientists even theorize that deep within their atmospheres, the intense pressure could be squeezing carbon into solid diamonds, creating storms of diamond rain. Once again, reality proved to be far more spectacular than our imagination. This is the very soul of scientific exploration. We build models based on the best information we have, but we must always be prepared to tear them down and build new ones when new evidence emerges. From the secrets of Mars' ancient past being drilled by the Curiosity rover, To Jupiter's shocking history revealed by its tiny moons, we are constantly reminded that we have only scratched the surface. The cosmos is vast, and its capacity to surprise us is limitless. And that is the most thrilling part. Knowing that with every new discovery, another, even bigger mystery is likely waiting just around the corner. Keep looking up.